Our last unit is the statistics unit, and we're going to start with scatter plots, correlation, and lines of fit. So a scatter plot is a graph that shows a whole bunch of ordered pairs that represent two numeric data values. Correlation is the relationship between the two values. So if the correlation is positive, both data values increase together. So for example, as you get older, your shoe size gets bigger up to a certain point, obviously. If the data has a negative correlation, one value increases while the other decreases. So be careful that you don't confuse that with both data values decreasing. That's actually a positive correlation. So an example of negative correlation would be as the temperature outside increases, your heating bill decreases. If there's no correlation, there just is no relationship between the data. A line of fit, and your book calls it a trend line, so you'll need to know that vocab too. A line of fit or trend line is a line that goes through the center of the data. So when you're looking at a scatter plot and you're looking at a bunch of ordered pairs, you try and make a line that goes through the center of the data, not hits the most data points. Sometimes it's the same line, but sometimes it's not. And finally, we're going to talk about causation. Sometimes one change in a data value results in a change in another. For example, the more you work, the more you earn. The result of increasing your work is increasing your income. But correlation does not always mean causation. So we'll see some examples of that as well. All right, so today we're going to be able to interpret scatter plots and use a line of fit or a trend line to predict data values. So the first thing we're going to take a look at is whether or not two data values have some sort of correlation. And if they do, is it positive or negative? So our first example here, we've got study time on the x-axis and test score on the y-axis. And as you can see, if we were to put a line through the data, the line is rising. If the line has a positive slope, there is a positive correlation between the data. Now in this case, some of the data values aren't real close to the line. I might call this a moderate positive correlation. But what this means in terms of the data values is that as study time increases, so does your test score. All right, so our second scatter plot, these data values seem to be all over the place. Looking at the two data, number of siblings and GPA. So what this means is there is no relationship between number of siblings and GPA. And our last one is time on medication and illness symptoms. So if we were to put a line through this data, it would be going down or decreasing, so this is a negative relationship. And what this means is, in terms of the data, the longer you're on medication, the fewer symptoms you have. So as one data value increases, your time on medication, the other decreases, your illness symptoms. I want to scroll back up to this first one real quick and touch base on that, both of them decreasing. So if we look at this first scatter plot, if your study time decreases, then your test score also decreases. That is a positive correlation. So make sure that you keep that straight with the negative correlation. The next thing we're going to do is try and create a line of fit or a trend line through this data set. So we have year after 2000. So if we're looking at a data value of 2, that would be 2 years after 2000 or 2002. And the population of Cottage Grove is on the y-axis, and that is in thousands. So if we look at, for example, this data value, that would be the year 2002, and the population would be about 32,100 maybe. Each of these half lines would be 32,500. for the population. So part A asks us to draw a line of fit. So what we want to do is try and get that line through the center of the data as best we can. So I usually use a ruler as I'm trying to create my line of fit, and I kind of position it so that I can see the center of the data, and I've got a ruler on the board and it's kind of drawing the line for me, but not very well. So I would not use this part of the line here. I'm trying to erase some of this. And the line that's there, oops, thought I had my marker. The line that's here is not a real great line of fit because it wasn't where I intended it to be. I didn't know the ruler would make a line. It's too low. There are too many data values above the line and not enough below the line, but we'll kind of go with this for now. To write an equation for the line of fit, we need two data values that are on the line. So I'm going to try and estimate a couple of data values here. I'm seeing maybe this one will work, and that would be 10. If we scroll over, I'm going to use 35.5 to approximate. And also because I thought my line was too low, so I'm going to kind of scoot it up a little bit. And then maybe this ordered pair. So 4, and it looks like it's about 33. So the first thing we need to do in order to write the equation of a line, if you remember, is find the slope, which is change in y over change in x. So I'm going to subtract my two y values and subtract my two x values. So that would give me a change in y of 2.5 and a change in x of 6. So what I'm going to do to simplify is multiply both of these by 10 in order to not have that decimal in my slope. And then when I simplify, I'm going to divide them both by 5. So I have a slope of 5/12. And then in order to finish writing the equation, I'm going to use point slope form. Remember, this is the one where we had the asylum. So the x-coordinate is opposite of what we think, and the y-coordinate is normal. So I'm going to use my ordered pair that was two integers. So I'm going to use the ordered pair 4, 33. So I'm going to substitute my slope. X minus my x-coordinate was 4, and my y-coordinate was 33. So to put this into slope-intercept form, I'm going to distribute my 5/12. And that would give me 5/3. So simplifying my negative 5/3 and 33. 5/3 is negative 1 1/3. So I subtract 2, I get 31 1/3 for my y-intercept. And last, I'm using my equation to predict the population in 2025. So there's two things we need to remember. The year was our x-coordinate, and it represented years after 2000. So the first thing I need to do is subtract 2000 because my x value is 25, not 2025. So I substitute that in for x. And then I'm going to go ahead and use a calculator to evaluate this. And it's approximately 43, and then I'm going to multiply by 1,000 because remember the y value gave us our data values in thousands. So I'm going to multiply by 1,000 and round to the nearest whole person, and I'm going to predict about 43,750. Our last slide here is looking at causation. So determine whether the data would have a positive, negative, or no correlation, and determine if you think there is a causal relationship. So our first example is if you're at a sandwich shop, the amount of turkey sold and the amount of ham sold. So take a minute to think if you believe that would be positive, negative, or no correlation, and if there might be something that would cause this relationship to be true. I would say there's probably no correlation. That would be my assumption. And there would be nothing that would cause the turkey to go up and the ham to decrease or vice versa. For B, a car's speed and its stopping distance, would that be positive, negative, or no correlation? And this one would be a positive correlation because as the car's speed increases, the amount of time it would take to stop, or the length that it would take to stop, would increase as well. And in this case, I would say there is a causal relationship. The speed of the car causes the stopping distance to increase. For C, GPA and amount of TV watched per week. This, I would assume, would be a negative correlation because as the amount of TV you watch increases, I would assume your GPA would decrease because you're not spending time studying and doing homework. And in this case, I would say it could be a causal relationship. The amount of TV watched causes your GPA to decrease, but it could be a third factor in your study habits and your time management skills. So in this case, I would say there is probably no causal relationship. Watching TV does not, in and of itself, cause your GPA to drop.